We've talked about planning for security incidents and how to respond to them. But an important part of dealing with security incidents is analyzing them after the fact. Much can be learned about why something failed to allow attackers to infiltrate systems or exfiltrate data. We can do this using the cyber kill chain. The cyber kill chain allows security analysts or technicians, like you and I, to be able to trace steps backwards that were taken for a successful compromise or data event related to data destruction, data theft, whatever the case might be. So by knowing more about exactly what happened, naturally we can prevent it from happening again. So that's the primary benefit. So let's talk about the 8 phases of the cyber kill chain. We know a lot of this already, so it's going to feel like a review. Reconnaissance. This is what attackers will do to gather information about potential targets. Number 2 would be intrusion. Now, intrusion can involve scanning and vulnerability scanning, as well as network scanning, and exploiting would be the next step. And when we looked at the Metasploit framework, we were actually exploiting a vulnerability. Now, the only vulnerability in our example was that we had a website up and running, so I guess you could call that a vulnerability. Step 4 of the cyber kill chain is to look at privilege escalation. Now, this is what attackers will do once they compromise a host. Remember, they want to get the most powerful account that they can so they can do whatever they want on that host. But then after they've owned that host, owned in air quotes, because they've compromised it, normally they're then going to scour the network looking for lateral movement opportunities. What else on that same network might they be able to break into? So that's step 5 of the cyber kill chain, lateral movement. 6, obfuscation, anti-forensics. Sounds quite interesting. What's that all about? Well, this is about covering your tracks, things like clearing log files, or maybe planting files on machines to maintain persistent access over time, but making them look like they are benign. An example would be using steganography. We'll look at an example of that a little bit later, but steganography is a form of obfuscation, basically hiding something in plain sight by masking it. So that would be one option or phase related to the cyber kill chain. After which we have phase 7, denial of service. Well, in some cases, that will be part of the cyber kill chain analytic procedure if that actually occurred. And finally, exfiltration of sensitive data. Now, you might look at this and say, well, we've had some security incidents in our network that didn't meet all of these phases. This is just a generic model. Not every cyber attack is going to fit nicely and neatly into this. But what we're trying to figure out here is how can we trace all of these possible attack vectors to determine how on earth someone got into the network and stole data. So we need to look at all of these things. Now, you're going to be able to find that information with the centralized security logging service. Now, there's another framework that we might also use for post-compromise analysis called the MITRE ATT&CK framework. Now, this one will allow us to detect that there's a threat that might have been realized. And again, we need to figure out what was done exactly and how did they get in and how did they steal data? The same kind of thing with the cyber kill chain analysis. So we're trying to identify the techniques that attackers use exactly to get in to compromise these things. Now, how can we mitigate attacks from occurring? Well, that's what we're going to figure out by looking at exactly how they occurred. What could result from this is you making a change to firewall rules that might have allowed the attack to occur, or how your alerting is configured for intrusion detection and prevention sensors. Maybe the alert didn't get sent to the appropriate technician to deal with the incident in a timely fashion. You might also deploy honeypot traps, because you might have a partial analysis of how a past security incident occurred, but you don't have the whole picture. You might want the whole picture. I want the whole picture, so what I would do is set up a honeypot. Honeypot, remember, is a fake decoy trap that looks vulnerable intentionally, and you're monitoring it thoroughly so you can learn about how hackers are getting into it. Another way that we can analyze security incidents is using something called the Diamond model. Now, this shows us how malicious actors, otherwise called adversaries, did it. How did they exploit something and get into the network or into a host? So the Diamond model then can stem from the use of honeypots, because what you can do is analyze honeypot logs to see exactly what happened. Now, the reason it's called a diamond model, if we take a look at the graphic, is because, well, it looks like we have a diamond at the top of which we have the adversary. That would be the attacker. We then have the victim at the bottom, whether that's an individual person that's been targeted through a phishing scam or a web server or an entire network. We have the infrastructure as the next part of the diamond model over which the attack was executed. That would include things like perhaps being able to break into a network due to weak authentication at the network level, such as being able to quickly crack a WPA2 wireless passphrase. Finally, this is all based on learning about what the capabilities of the adversaries are. How were they able to get in? Well, they were persistent, they knew how to run scanning tools, they knew how to find out what was vulnerable, and how to use exploit tools like the Metasploit framework. Now, finally, what we can learn from analyzing those incidents is the detailed techniques that were used, which we can then use to make changes to incident response plans. Now, we've talked briefly about incident response plans in that they can be automated. It doesn't have to be cybersecurity technicians running to the rescue, although that is an important part of it. Now, we're talking about SOAR, S-O-A-R, Security Orchestration, Automation, and Response. This is simply a way to automate incident response by writing scripts or having a workflow, including decision-making, to say, if this happened, go to this action. If another incident occurred, go to this second action. It's kind of like writing code if you're a programmer. So we can automate things like remediation while an attack is occurring. Make a change to firewall rules. Maybe make a change to an application deny list or revoke a PKI certificate that was being used. The whole goal of a SOAR solution is, of course, incident response, but more specifically, to reduce incident response time. So for the Security Plus exam, you might get a question related to which kind of a model can be used in order to trace a security incident after it might have occurred, not necessarily planning ahead of time, but tracing it backwards.